All right, we got our notes. So we're starting on example 7. All right, notebook paper people. So the instructions are different today, notebook paper people. Instead of finding the measure of the side indicated, we're finding the measure of the angle indicated. So yesterday we were learning how to find the measure of a missing side. Today we're going to learn how to find the measure of a missing angle. All right. And again, we're going to round to the nearest thousandth, so 3 decimal places. So go ahead and write down example 7, notebook paper people. How many notebook paper people do we have today? Oh, just a couple. Okay.
I was like, what's the point of raising your hand?
I just wanted to see who's going to take a little bit more time today.
I was explaining.
Yeah, you're good. You're good. All right, so same as yesterday, we're going to look at the sides that are given, and we're going to write down their names. So based on the theta, which is right here, this is the angle we're talking about, what is the name of the 13 side? Hypotenuse, okay. And then what is the name of the 11.4? Adjacent. So if we have the hypotenuse and the adjacent, then which trig function are we going to use? Cosine, okay. So we have cosine, and since there is not a degree measure given, we're just going to write theta. So I'm going to say cosine of theta equals, and then I'm going to write adjacent over hypotenuse. So I'm going to say 11.4 over 13. Now, if you guys remember, theta is the variable that is typically used in these types of problems. I think the punchline worksheets, they were being kind to you and using just regular English letters instead of theta. But theta is what they use outside of punchline worksheets when they're trying to be nice. So theta is one that you'll expect to see all the time. It's just pretty common. So if we're trying to get rid of theta, then if we're trying to get rid of the cos to get theta alone, what we do is we want to do the inverse operation. So if you guys remember, inverses, has anyone heard that word before, inverses? They're operations that undo each other. So plus minus, multiply, divide. You guys have done inverse operations before. So if you look at your calculator, you can actually see the inverse operation on your calculator. Above the sine button is sine inverse in blue. Above the cos button is cos inverse in blue. Above the tan button is tan inverse in blue. So tan inverse undoes tan, sine inverse undoes sine, cos inverse undoes cos. So what we do is we say, I want to get rid of cos, I'm going to do cos inverse on each side. It's kind of like dividing by cos, but not really. It's how we get rid of it. So if you say, I've got a cos, I want to get rid of cos, then cos inverse and cos cancel each other out. So we have theta equals cos inverse of 11.4 divided by 13. So this right here is the exact answer. But if somebody said, hey, what's the degree measure? And you said cos inverse of 11.4 over 13, they'd be like, that is absolute nonsense. I don't know what you mean by that. And so you'd say, okay, let's get it in my calculator. So since cos inverse is in blue, we're going to hit the second button. So we're going to do second cos. But before we do that, we have to make sure our calculator's in the right mode. So everyone hit the mode button. Let's just make sure we are still in degrees from yesterday. Everyone check, are we all in degrees? Okay, so we're going to do cos inverse, and we're going to type 11.4 divided by 13. 11.4 divided by 13, what did you guys get? Okay, so we're going to say theta is approximately a 28.727 degree angle, and make sure you get that little degree bubble in there because it is an angle that is measured in degrees. So this, we're going to write this down. This is the exact answer, and this is the approximate answer. You do not have to put the squiggly equal sign. You can just put a regular equal sign. You do need to put the bubble to show that it's a degree measure. Okay. Nobody writes the exact answer. Everybody writes the approximate answer. Okay. Any questions about how that works? There isn't really, in Math 2, there isn't really a more difficult version of this problem. They are all about the same level of difficulty. So the way okay. All right, let's try the next one. So here's our theta. Let's write the names of the sides. So what's the name of the 13? Hypotenuse, what's the name of the 7? Opposite. So what trig function are we using? Sine. So we're going to say sine theta equals 1/13. Okay, and then how do we undo the sine so that the theta is by itself? We're going to do sine inverse, sine inverse. So sine inverse and sine cancel each other out, and we just have theta equals sine inverse of 7/13. There's our exact answer. And so our approximate answer is going to come from the calculator now. We're going to do second sine. So there's our sine inverse of 7/13. And what do you get? 2.57. Perfect. All right, here's the theta. What should we call the 2.6? Opposite. What should we call the 9? Adjacent. And so what trig ratio are we going to use for number 9? Tan. So we're going to say tan theta equals 2.6/9. And then what are we going to do from there? Tan inverse. And what do we get? 16.113. How are your brains? Your brains feeling good? Yeah? Okay. We liking trig so far? Yes! Good. I love me some trig. All right, so we're going to say this one is, it gets, so remember I said, I can't remember, we're doing trig in Math 3 right now too, so I can't remember if I said this to you guys or if I said this to Math 3, but one of the reasons I love trig is I think it's a good combination of geometry and algebra. And so far, we haven't seen the way that algebra plays into it. We've only seen the geometry. We've only seen the triangles. So I think some kids, it kind of depends on how you feel about starting to make the discoveries. So some kids, as they see there's more and more relationships between things, they go like, Will it never end? Why are there more and more relationships happening? And it frustrates them. And then there are some kids where it gives them a sense of wonder, like, oh my gosh, there's another relationship that happened. That's so cool. So the same thing that might excite someone like me might frustrate someone else. Does that make sense? So every time I learn another connection in Trig, I'm like, oh my gosh, that's the coolest thing I've ever seen. I would never expect those two things to be the same. Whereas a kid would see that and be like, how in the world does that work? I freaking hate that. So it kind of depends on where you fall in that, if that would frustrate you or if that would be cool. So some kids hate it for the same reason that I love it. So, all right, hypotenuse. Okay, so this one is sine theta opposite over hypotenuse. So for the punchlines today, one of them you're going back to solving for missing sides, and then the other one you are practicing solving for missing angles. And then we'll try to get both of them done. Get them turned in so that we don't have to worry about losing them over Thanksgiving break. Okay, did everyone get 35.685 for the last one? Yes, marvelous.